Good afternoon. I take some breaths not to be too much afraid in front of you. So the stall and upset recovery training, a little update. We did a lot of presentation on this in the past, but I will update you what we have done since the last conferences that we have given, either in flight safety or here in flight operations conferences. So a small introduction. What came out in a few years ago is the Aircraft Upset Prevention and Recovery Training Aid. The document has been published by the ICAO. It's available on the ICAO website. This document has been created with all the major aircraft manufacturers. And now, actually, there is a little revision that will come out soon with some minor updates in the text. So very soon you will receive probably a push, or you have to go onto the website and see what changed in the document. But basically the regulations remains exactly the same. What is the Airbus answer to all these things that we have in the regulation? So first it was to introduce prevention of an upset. So see that pilots can recover from this situation, even if they are startled. And redefine what is an aircraft undesired state towards a stall. We were complying with this basically just by having this revision 3 document, but we said this is not enough. So let me come back and refresh our mind. What is an undesired aircraft state? As you know, it's not based anymore on bank angle or pitch attitude and so on. It's really that the aircraft starts an unintentional diversion from parameters normally expected during the operation. This could be pitch and bank divergences, but also speed. You can have moments in your flight where the speed is decreasing without you ordered it. So this is basically an upset of the aircraft, an undesired aircraft state. The regulation now, regulation-wise came out. We had regulation in the EASA and in the FAA. We did communication towards our customer. I will come back later on this, what we have done. And basically to the trainers, we had to explain as well why we need this new training. And we provide them as well with training recommendation, what is the best practice in order to complete this training on upset recovery. On my slides, you will see 2 icons, sometimes one on the top right corner. One will be a cockpit. This means that this slide is really dedicated to flight crew. And if you see a simulator, this means that this slide is really dedicated to training devices. Regulation-wise, we have EASA and FAA, and we have as well 2 parts. One part is for the aircrew, so for the pilots, and the other one is linked to the FSTDs, or the full flight simulators. In the FAA part, we have regulations in part 121, and in the EASA, we have as well in part FCL, UPRT, and stall training. For the training devices, we have regulation in FAA, which is called Part 60, with a change 2, where they impose more things that your simulator must be able to do. And very recently, the EASA came out with a CS on FSTD, issue 2 as well, with full capability of the stall training. Based on all this information that we have reviewed, we have seen the need in Airbus that we have to issue a new data package not only for the full flight simulator, but as well for the flight crews. For the full flight simulators, the FAA part change 2, so if you follow the FAA regulation, you have to comply with this. It requires that your FSTD must be able to do upset recovery training, must be able to do stall training. The regulation has been published in March 2016. And if you do upset recovery training with your device, you have to do this before 12 March 2019. From that day on, all your training devices in which you perform upset recovery training or stall training must be complying with the FAA Part 60 Change 2. On the EASA side, as well as I said, we have an FSTD, CS-FTD that came out, where full stall requirements must be available. But the regulation in Europe in EASA doesn't impose to do full stall training as compared to the FAA world. So it's up to the operator to decide to do full stall training. But EASA only said that you have to recover from the first indication from a stall. It has been published, the directive in 2018-06 on the 3rd of May of this month. It's based on UPRT as well, stall training, and it's basically harmonized with the FAA. So we have two similar regulations now in the world. And the Airbus answer for that is to have a fully compliant flight simulation training device. And we introduce something new, what we call the automated stall entry function. I will come back later to this. This is something that we have developed, and we are sharing this with the simulator manufacturer in order to introduce this in your full flight simulator. On the FSTD and the automated stall entry, so what does Airbus deliver actually? We have a simulator data package that we provide to the simulator manufacturers. It's fully compliant with the Part 60 Change 2. This means that you have a total free play capability, so you can enter a stall and you go into the you can fly the aircraft into the validated training envelope of the aircraft. So remember that in a full flight simulator, you have different envelopes. So you have the envelope where we went into flight test, which is completely validated. A little bit bigger envelope in which you can fly is the engineering data. So we extrapolate some of the data that we have encountered in flight test, but the aircraft can fly in there. And then we have a validated training envelope. This means that the simulator can fly within an envelope, and if you pass this envelope, the simulation will freeze. As an example, if we do stalls with an aircraft, in flight test aircraft, depending on the configuration and so on, we go to 16, 17 degrees angle of attack. By engineering, we can say we can go up to 20, 21, but the full flight simulator can go up to 30 degrees angle of attack. But we don't know if it's really completely representative. Based on that, we have as well reviewed the stall buffet model. As you all know, that buffet is one indication of a stall. And we have seen that in a lot of simulators, this model was really not correct or representative of the aircraft. So later on, I will discuss with you what we have done. And another thing that we have introduced in the simulator data package is the roll-off model. What is the roll-off? Is basically a wing drop during a stall. In order to have the capability to play with the full flight simulator and do correctly the exercises, new functions are required for the instructor station. So we have sent the documents to the simulator manufacturer as well in order to introduce these pages. We have some dedicated function as well for UPRT and stall scenarios. So with the scenarios, you can introduce startle or fear in the simulator. And those pages will as well give feedback to the instructor in order to debrief the trainees. To come to the aerodynamic model that you need to have for the complete stall and to be compliant with the regulation FAA or EASA, these are all the points that you have. Basically, in the first model that we have provided, that our Department of Simulation data is giving you or to your simulator manufacturer, we had all those points which were already in. Now, the points which were not in are what? Are the uncommanded roll response and apparent randomness or non-repeatability. This means that we have to introduce wing drops in the stalls and the stall buffet model. If you have all this in your model, you're fully compliant with the regulation. To give you some more detail on the roll-off model, what is the roll-off model is basically we went into our database of flight test and we looked to the hundreds of stalls that has been done during the flight testing of an aircraft. We looked how much time we had a wing drop, and we decided to recreate this roll-off model in our simulators. First, we did it in our engineering simulator with the right computers, the prims and the secs that we have. And then we generated this model in the data package, and we tuned this in the full flight simulator. We have seen sometimes in the world that some simulator manufacturers or providers from stall devices in the full flight simulator were really not realistic. You can ask even Wolfgang that basically most of the stalls that we have, our aircraft will remain wings level. And we didn't want to introduce in the training devices scary situation with very big wing drops, so we really wanted to have the exact reproduction of the aircraft. And one of the key things that we had to do during the tuning in a full flight simulator is to introduce a kind of yaw acceleration in the movement of the motion in order to really and correctly simulate the swing drop in the aircraft. So this has been done. For the buffet model, so the buffet model again is based on stalls performed during flight test. The main driver or to induce this buffet is the angle of attack. Of course, the buffet is in function as well of the Mach effect, the configuration of the aircraft and so on. And this model that we have gives a realistic input into the motion. Now, we had sometimes complained that by doing this kind of motion movement, it could destroy or damage a little bit some parts of the simulator. We have seen simulators where parts of the ceiling were coming down, but this is really the real buffet model. What we did is that we went, you have the different graphs over here, where we have what we did in flight test within the magenta line, and the dotted magenta line gives the reproduction into the full flight simulator. On the lower two part, we have worked on two important information as well for sensation in the pilot seat, which is the vertical vibration and the lateral vibrations. So we have put in the full flight simulator accelerometers on the pilot seat. And we have compared this because during stalls that we do in the aircraft, we have accelerometers on the pilot seat. And we have compared those two models. And we went to simulator manufacturer in order to tune this and to put this really in a data package. So if you have the fully validated data package that we provide, you have exactly the way the aircraft behaves. And you can show those symptoms to your trainees. This is for the aerodynamic model. For the functions for the instructor, we have sent a document towards the simulator manufacturers. Recommendation for some pages in the instructor station, and as well some scenarios for upset recovery and stall scenario activation. What I just said before, the automated stall entry. So this is typical for an A350 simulator that we have in Toulouse. It's more prototypes. One page that you have to provide to the trainee is what we call the alpha-beta plot. This means it's the angle of attack and the side slip during an exercise, where you have the limits that you see where you're going to have the stall warning, where you have the critical angle of attack, where you have the full stall situation, that you really see how the aircraft behaves and how the recovery training has been done. The second page that you must have in your simulator to do correctly upset recovery training as well is what we called the load factor and speed. You know, this is the flight envelope of the aircraft, where you have this 2.5 G positive and up to -1 G in negative. And you see as well how the trainee recovers. If you see him going all over the place on the page, this means that the recovery technique was not correctly done, and you have to repeat this until he's proficient in the recovery of an aircraft. A third page which is available is a kind of plot, second per second, where you see all the different parameters of the aircraft. The fourth page that we have is a summary of all the pages, where you have as well a picture of the primary flight display and a position of the flight controls during recovery. If you do recovery, it's not easy as instructor to see what the pilot is doing with the side stick or with the rudders. So from that page as instructor, you can clearly monitor how the recovery is done. Of course, all of this can be recorded and can be replayed in the briefing station or in real time if needed in the full flight simulator. The last page that we have is basically the maneuvers and the scenarios. So we have on this one two parts. One is what we call maneuver-based scenario. This means that we will introduce the aircraft into an upset. Could be nose high, nose low, high speed, low speed, with bank, without bank. And the simulator will be frozen at that position. This means that this is used basically in order to teach and to recognize upsets. That you can, everything is frozen, and you explain to the trainee, or he has to discover in which state the aircraft is. The issue with this kind of simulation is that at the moment you release the full flight, because the situation is frozen, the motion is not kicking in at the same moment. So if you do recovery from that position, the time that the motion is coming in could give negative reactions to the pilot or do negative training. This is why as well we recommend for big upset recovery training to disconnect of her, not to use the full flight motion. The right-hand part of the screen, we have scenario-based training. This means that you can induce, without pilot knowing it, so startle effect, some changes in the aircraft behavior. On that you can do with light, moderate, or severe effects. Then in the middle we have introduced two new functions. They are called now before stall or at the stall. The name can change. And this is basically to answer the requirements of the FAA on part 121, which would require a full stall training. So this means that the pilot has to go beyond the stall warning until the aircraft is stalled and recover from that position. Is this easy to do? Do you think? No, it's not easy to do. First thing, do you know when the aircraft is really stalled when you're in a full flight simulator? Not easy to define. Even for us at flight test, when we do stall training, and stalling of the aircraft, we have a flight test engineer in the back who is yelling to say that the aircraft is stalled because we don't feel it in the cockpit. So he can see on the instruments in the back when the lift is disappearing and that there is a kind of G-brake, what we call, that the aircraft is coming down to say, look, there the aircraft is stalled. Full flight simulator, very difficult to discover. And the second part, which is quite important as well, we want pilots to recover at the first indication of the stall. First indication of the stall could be the stall warning or buffet or other symptoms, wing drop or non-responsive flight controls. And we don't want pilots that when they are into the stall, that the stall warning is yelling there in front, stall, 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 cling, 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 stall, 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 that you say to your trainee, continue to pull in the side stick in order to go to this full stall. This is why we came up with the idea of what we called the stall demonstrator. What is the stall demonstrator? We have two scenarios in there. The first one is a kind of what we call the stall demonstration. This means that hands off, you say to your trainees, imagine that somebody else is flying the aircraft, or you sit in front, and the aircraft will decelerate towards the stall. When the aircraft reaches the stall, the angle of attack stall, the aircraft will stay at that position, the motion will not freeze, and the aircraft will continue fly at the stall position. So this really is a device for teaching. And at that point, you can say to your trainees, look, this is the pitch of the aircraft, this is the angle of attack. If you use the bird to have the pitch minus the FPA gives you the angle of attack. Look what is the vertical speed is doing. Feel the buffet that you have at that time in your seat. Try to remember this. Have your memories wakened up to remember those phenomena. And when you're at that position, at any time you can say to the trainee, recover. So this means that the motion is alive in this position because it simulates the buffet. And at the moment that the pilot touches a side stick, he can do a full recovery from a stall situation. So this was our way in order to answer to the FAA. The FAA have given us feedback on that, and they said it's a very good starting point in order to do full stall training. In the future, we will have still discussion with the FAA in order to have this fully, I will say, approved or put somewhere in a document that this is really what they have to do. So this is the first part. The second part that we have is what we call the full stall exercise. This means that there as well you can stall the aircraft and introduce wing drops and so on. And the idea in this exercise is to say that, imagine the other one is flying, the aircraft starts to decelerate, your pilot monitoring, and at once you start feeling the buffet, and you have to recover from that situation. And we have done this in such a way that we went up to the stall angle of attack plus a few degrees. So if I say it's stalling at 6 degrees, I have to say, imagine we went up in the simulation up to 9 degrees. If you reach 9 degrees, the simulation will stop. This means you went too far and you missed a lot of cues in recovering from that situation. You can do the same by introducing wind drops, so roll-off models during this training, and you can see if the pilot has the good competencies in order to recover from this stall situation, which is what? First, reduce the angle of attack, so push on the side stick or release the side stick. So in a nutshell, in order to summarize, if we look to the stall, we have two positions. Either we stay and we simulate the stall at the stall angle of attack by keeping the motion on, or we go to a point a little further where you have to recover. So this data package is available in some simulator manufacturers actually, and we continue to validate this. Because what? In order to have this, we have to provide you with a state of compliance. Either you do it yourself or some other people can do it. What is the state of compliance for your FA Part 60 Change 2 or the ESA? You need the three models, the aerodynamic one, the roll-off and the buffet. You have to be compliant with the QTG's, Qualification Test Guide. You have to have the good simulated envelopes. And there as well, it's stated in the document, the status of compliance included a final subject matter expert assessment. Well, we went into the regulation to say what is a subject matter expert in stall. Everybody can say, I'm a subject matter expert in that. What does the regulation say for the subject matter expert? The friend of Dominique Himeta, Chuck Yeager. The guy has to be type-rated qualified in aeroplane that is simulated. So you cannot ask a guy from the B company to validate the stall of an A company aircraft. Second thing, he must have direct experience in conducting stall maneuvers. So you don't find this at every corner of a street. The subject matter expert can have credit for different models aircraft. This means if you're familiar, I will say within the Airbus family stalling of aircrafts, 330 and you want to do the 340, you can have credits for that. And the subject matter expert must be familiar with the stall training maneuvers that will be done later on in the FSTDs. So you see that the person who is going to validate your stall model in the simulator must have knowledge on really stalling in order to have, again, a statement that what is simulated is realistic, is basically the aircraft. Do we have those models in our data package? Yes. So for the 320 family, I have the standards over there. The 2.0 is fully compliant. We have for the 330 CO in the standard 2.6. The 330 NEO, since we are still stalling the aircraft and doing some testing with the aircraft, this will be later in the standard data package. We have it for the 350. And on the 380, this is just, we don't have a full data package, but we have an add-on to the actual data package in order to have the compliance matrix with the regulation. So in order to summarize what we have, for flight crew training, you have the upset recovery training 8 revision 3. You have a lot of information on stall and upset in the FCTM. You have the stall training video, which is as well available on the application that Maxime showed you the win. You have documents from EASA, FAA, ICAO, IATA, and so on. And of course, we have in our training organization, the ATO, Matthias will explain this immediately, what kind of training program that we have in order to fulfill with the stall requirement from the regulation. For the other material that we have, so we have given you and providing you with OTTs and what we call SPOT. SPOT is simulating product operator transmission. So we have the undesired aircraft state. the use of FSTDs and the data package for the UPRT. And of course our simulator, we have the full stall data package that we have. You can have the functions on the instructor station in order to complete this training, and you can have the automated stall entry in order to perform correctly and to demonstrate to your trainees what is the correct behavior of the aircraft during the stall. Now, I will let Matthias conclude with the training material and the training that they provide in our training organization.
Thanks, Gwyneth. Thanks, Xavier. Good afternoon, everyone. It's my pleasure to be with you in order to conclude basically on what Xavier just mentioned for what do we have in the training organization, in the Airbus training organization available to support you as our customers. I think we have, if I may say, and do the link as well to what Florence presented just before. We will see that from a training organization point of view, and for all what was presented, not only in terms of tools, but as well in terms of regulation, we have to develop a final product which we can provide to you, which we can offer to you, but not only to you as customers. We have the same question for us internally in the training organization, because we have to train our pilots and instructors as well. And I think that's a key point. So basically the answer, and that's the conclusion of my presentation, is yes. Obviously, as a training organization, we have integrated all this in our type ratings. And this is why, for me, just compared to our presentation in the symposium in Berlin about 2 years ago, and we mentioned it by Jean-Michel and as well by Chris in their presentation, we have integrated this in the type rating. So the A320 and A330 type ratings were renewed last year. They were put in place in November. And part of this renovation as well was in order to introduce all the upset prevention and recovery training requirements. And one item we had to address as well, and we have seen it in the presentation from Xavier, we have so many different regulations. We have FAA, we have EASA regulation, and on top, our training organization is spread worldwide. So as well, we have to tackle with different national authorities as well and some local requirements on top. So the way we decided to move is to develop what we call an Airbus standard, which is a type rating course, advanced training, but as well with the aim to satisfy basically worldwide regulation. It's quite ambitious, and we've succeeded very well today with a lot of national authorities already accepting the training program. So for the pilot type rating training, the answer is yes, it is incorporated. The next item we looked into is the recurrent training and checking program, both for what we can provide to the customers and same what we can do for our instructors within the training organization. So the status here is on top, and this is as well in what Xavier just mentioned, we provide the operational training transmissions, the OTTs. They are obviously as well to be integrated, but more than this, not only UPRT requirements, but as well requirements coming from safety information bulletins, safety information letters were taken into account into our internal and external recurrent training and checking program. Moreover, now specifically to the UPRT, we developed 9 modules which we provide via e-learning, and they cover as well the theoretical knowledge compared to UPRT. You will find those elements incorporated in the type rating training, but as well being available for the recurrent training part. And obviously, I like to invite you to see me at the booth outside where we discover ACE, and obviously they are part of ACE as well, and I'm more than happy to share with you what we have done on those training tools. And last but not least is we tackle as well the area of, okay, we have it in the training program type rating, we have it in recurrent training, but what do we do for instructors? And I really like to highlight a lot, and I like to link this very much to what Florence just mentioned before. we believe that training our instructors is key in all this. And I will come back to this in a bit later. So first of all, in the UPRT, as I mentioned, is integrated in the type rating training we offer today. We introduced it on 320-330 by reworking the type rating course and on top implementing the competency-based training. And on 340 and 380 we decided to have an additional full flight simulator session as being part of the type rating course in order to tackle the UPRT training requirements. Now for the recurrent training, we base the recurrent training on the 3-year cycle. Theoretical part, as I just mentioned, are the 9 modules available via e-learning, and the exercises are integrated in our full flight syllabi. So the way we managed is that we have a standalone session to cover all the UPRT elements as a sort of delta, as a gap to what was already there in terms of a 3 years training program, in order to ensure that we are compliant with regulation, but as well with our recommendations we provide to our customers. And last but not least, on the instructor training, we do have a few prerequisites, because what we believe is, and this is what Florence mentioned in her presentation, is one way of experiencing fear is you do the training as instructor, but before you do as pilot. So you experience yourself. And I think that was a key message shared today. So this is why the instructor training we propose is based on the assumption that the instructor candidate will have done UPRT training as trainee already. Because it is not only to experience yourself as an instructor later on, what does it mean to be training on these kind of courses, because it's very specific to all the elements, because we have some key elements as well to tackle. And we heard a lot today, avoid negative training. And for me, this is a key message. And doing UPRT training and we scare our pilots later on is not helpful. So this is why we need to be very cautious with the guidelines we provide to our instructors and how to make sure that our instructors are competent to perform this very specific training. On top, we learned by Chris the 5 new instructor competencies as defined. Chris mentioned already they are taken on board in Airbus development on top. And one of the 5 was competency as pilot. This is as well why we believe that the instructor training can only be an add-on to a pilot who has been already experienced UPR training as a pilot. The way we do is, obviously there's a knowledge part, but on top of the knowledge part we have a classroom training and in addition a full flight simulator session. And we had the pleasure some time ago to work together with our colleagues from Flight Ops and Training Standards in order to develop a core team. And the main question for us was, what kind of syllabus do we develop? What kind of syllabus is adequate for what we would like to achieve? And this is the way within the Airbus training organization, later on, how we qualified our own instructors. So just to give you a figure, last year we had to train more than 300 instructors as pilot on UPRT, and on top, the same number of instructors as UPRT instructors, because key element is as well, when we integrate UPRT in the type rating, so we must make sure that the instructors providing type rating training are as well UPRT instructors. So this is the way how we closed as well the loop. So therefore, I'd like to give you a quick conclusion. So what's our Airbus? We have an answer to the regulation, both as well for the tools, as just explained by Xavier, and as well same for the training organization and our training programs. We have aircraft models updated in the simulator. We have the automated stall entry. We have our updated manuals our publications, including OTTs. And on the training side, we have updated our type ratings, the recurrent training and checking program, as well as the instructor training. Thank you.